Hi everyone, welcome to our pre-calculus course. To begin, we'll start off by reviewing some basic algebra and notation that we'll need for this course. So firstly, we have sets. So a set is a collection of objects. Oftentimes, visually, we would see it represented as an oval or a circle with items inside it. Okay, these items or objects are called elements. So in terms of symbols, normally for a set, we denote it with a capital letter. So for instance, we can have this set to be set S. And then to let the people know what is and is not inside it, we can use these symbols over here. So the first one here, X is in S, which shows that X is a member. Alternatively, if X was not part of this set S, we would write it this way instead. X is not a member of S. So let's take a look at an example. Let's say we have the set S that contains three things: 8, pi, and 4/5. We would then be able to state that pi is a member of S. Meanwhile, 2, we can see, is not one of these three elements, and so we'd say 2 is not in S. So we also do have some common sets in math, so let's go through them. Firstly, we have natural numbers. So this is denoted with a capital N, and these are just the natural count of numbers, 1, 2, 3, 4, 5, and so forth. We also have integers. So integers are whole numbers that can be positive, negative, or just 0. And then that extends forth both negatively and positively, and represented by the letter Z. We also have rational numbers. So this is denoted with a Q, and these are numbers that can be expressed as a fraction of two integers. So for instance, we can have minus 1.25 or 16/24. These are both examples. And all of these all belong to the set of real numbers. There's also a category irrational numbers. So these are numbers in the real that are in the real set, but do not belong as rational numbers. So some example of these would be pi, square root of 2, which you may recall has an infinite number of decimal places with no patterns. Of course, we do need to be able to denote sets that are more specific than these number classifications. So here is an example how. So we can create set S over here such that that includes x such that x is an integer, and squaring x will result in 16. So here we've listed out what properties the elements of S must have. And in this case, we can actually see that S is a very small set with just the numbers 4 and -4. We can also have just an empty set, so that's just represented with a circle with a strike through it. Now that we can define sets, let's go ahead and explore more on the relationship between different sets. First, we can check if two sets are equal. So an example might be here. 1, 2, 3 is equal to the set 3, 2, 1, equal to the set 1, 4/2, 3. Note that order does not matter, and also the way we express it doesn't matter as long as they are equivalent. So 4/2 is just equivalent to 2. We can also state that one set is contained inside another. So we use the word subset to represent that one set is contained inside another set. So some examples might be the natural numbers is a subset of Z, which is a subset of the rational numbers. We can also, if we want to go beyond that the rational numbers are a subset of the real numbers. Intersection gets the common elements between two sets. For example, if we were to find the intersection of the set -2, 4 and the set -4, 2, we would find what is common, which in this case is just -2. On the other hand, the union of two sets gets all the elements in both sets. So if we were to look at the same sets as before, to find the union, we would get all the elements contained in both sets. But note we do not repeat elements. So -2 will only appear once in the union description, even though it appears twice over here. Another common type of sets are intervals. These are sets of real numbers that fall between a pair of numbers. So to represent it, we can use different types of brackets depending on what we are looking for. We use square brackets if we want to include the endpoints, and round brackets if we want to exclude it. So for example, let's say we have our number line, and we wanted to create an interval between 0 and 2. If we wanted to exclude 0 and 2, but include all the numbers in between it, we would use round brackets, 0 and 2 inside round brackets. If we wanted to instead include 0 and 2 in our set, as well as the numbers in between it, we would go ahead and use square brackets. Okay. Do note also we can have a combination of square and round brackets depending on whether you want to include or exclude the start or end number. Also note that if you are using positive or negative infinity in your description, we use round brackets and not square, since infinity itself is not a precise point. We'll also go quickly through some rules of inequalities. So if we have two numbers a and b, where a is greater than b, and we have another number c, such that b is greater than c, then we have this inequality here, a is greater than c. Next, if we have two numbers, again, where a is greater than b, and we have a third number c, which is positive, if we multiply both sides by that positive number, we still have an inequality in the same direction. On the other hand, if we have a is greater than b, but c is negative, if you multiply a and b by c, we would go ahead and reverse the inequality direction. Finally, we have the absolute sign. An absolute value is always positive, and so removes the negative sign out of any negative numbers. So if a is negative here, it finds -a, which in turn would be positive. One useful property that uses the absolute sign is the triangle inequality. So where the sum of two values, both contained inside the same absolute sign, is less than or equal to the sum of those values in their own absolute sign. Another way you can think about this is that if we have two magnitudes, right, if we have the combination of those two magnitudes can't exceed the parts. To wrap up this section, let's go through an example. So we have the inequality here, 0 is less than x minus 5 absolute, which is less than 2. So let's go ahead and break this up into two parts. I'll do the first half, which is x minus 5 is greater than 0. Now, by property of the absolute sign, we already know that x minus 5 in absolute cannot be negative. So the only part I need to consider is when might x minus 5 be equal to 0, which we can tell is when x is equal to 5. So I know that x cannot be equal to 5 for this solution. Okay, and then now let's go ahead and do the second half, which is x minus 5 is less than 2. To be able to approach this further, I want to get rid of the absolute signs. And again, by looking closer, I can see that if I get rid of the absolute sign, x minus 5 must be between minus 2 and 2. So let's write that out. X minus 5 is between minus 2 and 2. So now I can easily solve for x by, I'm just going to plus 5 to all the sides. Okay. And then let's not forget to combine both of our results from both halves. Okay, so I can see that x is either between 3 and 5, or is between 5 and 7. And here are the solutions for this inequality. And so that wraps up our algebra review. Next time we will be going into quadratic equations.